As HPLC analysts, we often encounter issues such as poor peak resolution, excessive peak broadening, or early elution, and struggle to find the right approach to adjust the conditions. In this video, we explore the principles of separation in reversed phase chromatography, addressing these challenges at their root. First, we introduce the concept of polarity. Polarity refers to the distance between the centers of positive and negative charges within a molecule. The greater this distance, the higher the polarity, and vice versa. Most compounds exhibit some degree of polarity, as the centers of positive and negative charges cannot completely overlap. However, when a molecule has perfect or highly symmetrical geometry, it can be nonpolar as well. For example, methane, ethane, benzene, and linear alkanes. Each target analyte has a fixed level of polarity, so we can quantify and denote as A. Likewise, the polarity of the stationary phase of an HPLC column can be denoted as B. Since C18 is structurally highly symmetrical, it has very low polarity, we can generally assume that A is higher than B. Now let's consider the mobile phase. In RPLC, the mobile phase typically consists of high-polarity solvents, such as water and methanol. Water has a polarity of 10.2, while methanol has a polarity of 6.6. Since compounds are retained in both the mobile and stationary phases, their polarity values are usually less than 6.6. The mobile phase polarity, C, depending on the ratio of water and methanol, falls between 6.6 and 10.2. Among these three polarity values, the mobile phase polarity is the only adjustable parameter. During separation, compounds continuously distribute between the stationary and mobile phases. When the methanol ratio in the mobile phase increases, the overall polarity of the mobile phase decreases, reducing the polarity difference between the compound and the mobile phase. Since, like dissolves like, the compound becomes more compatible with the mobile phase and elutes faster. If we introduce a new compound into the system and denote its polarity by D, assume D is higher than A, then D has a smaller difference with the mobile phase's polarity, meaning compound D is more compatible with the mobile phase than A. As a result, D elutes earlier than A. This explains why, in RPLC, compounds with higher polarity elute earlier and why different substances can be separated. If the resolution between compound A and D is insufficient, increasing the proportion of water in the mobile phase enhances its polarity. This slows down the elution of both compounds, extending the overall separation time and increasing the retention time difference between them, ultimately achieving better separation. We hope today's discussion helps laboratory analysts gain a deeper understanding of chromatographic separation principles and effectively solve common challenges.